Welcome everyone to our Simio Solutions series. Our first, our first one of a kind. We are going to be doing these on a bi-weekly basis. So good morning, good afternoon, good evening to everyone. My name is Dan Vasilini. I am the VP Global Sales here of Global Sales here at Simio. Joining me today and doing most of the talking is going to be Adam Sneath. I'll let him introduce himself here in a second, but he is one of our solution engineers at Simio. So before we get started, a few housekeeping items. So today's session is being recorded for replay purposes. If you'd like to go back and watch this session or suggest to a friend or a colleague in the very near future, you can visit Simio's webpage, simio.com, and you'll be able to see links for this and all future webcasts. Also, so everyone is aware, you will enter this session in mute only. To ask a question, what we ask is that you go to the Simio, go to webinar dashboard. On my screen, it's located on the right side. You may have moved it around, and there should be a question box or a question drop down in the dashboard. Please type your questions in there during the session today. Today's session is scheduled to last about 60 minutes. We have intentionally left about maybe 5 to 10 minutes left at the end for Q&A. So we do encourage any type of questions that you may have during today's session. Next, I wanted to point out our upcoming series that we do have already on the calendar. So we have them, like I mentioned earlier, we're going to be doing these bi-weekly on Fridays to start off with. So May 20th is going to be our next one on constraint logic, and then you can see the ones that are occurring in June. Two things that you will see or you will hear following up on this session. So first and foremost, you will be getting a survey. And in that survey, what we're going to be asking is for everyone that's registered and everyone that's attending, first and foremost, are Fridays an okay day to have these sessions on? We've already set our next 3, so these will be occurring on Fridays, but we know that different companies, different parts of the world, sometimes Fridays may be off, sometimes companies may work 4 days instead of working on Fridays. So if Fridays are not a good day, we are going to ask if you have a suggestion. And then secondly, in the survey, we are looking for future topic suggestions. So you can either send me, that's dvasilini@simio.com. You can see my email address right at the bottom of the screen. You can send suggestions directly to me, or in the survey, we will be asking for any type of suggestions on future topics. We have a whole slew of topics that we have in our minds on what we would like to present, but obviously from a customer perspective, if there is something that you would like to recommend or something that we think would be great for the rest of the world to hear as well, please recommend it, and we will indeed add it to our calendar at some point. So with that being said, I will turn things over to Adam. Adam, if you want to grab control of the screen, I'm going to stop sharing my webcam to eliminate bandwidth issues. The screen, I'll let you know when we can see your screen.
Great. Thanks. I'll take over the screen in just a minute. Thank you, Dan, for setting the stage. Welcome, everyone, to the first Simio Solutions series. My name is Adam Sneath. I'm a solutions engineer at Simio. I work primarily with our newer customers, really focusing on ramp up and training and first project success. Maybe you've worked with me before. I saw some familiar names here in the audience. We're really glad that you joined us today, and I think this is going to be a fun session. I hope you think so too. So we'll turn the webcam off while we're actually getting into the good stuff, and I will take control of the screen and start with a couple slides. And it should be coming up in just a moment. Dan, can you confirm that I'm sharing screen? Does it look good?
Yes.
All right, very good. So our topic for today, as Dan pointed out, is results and dashboard reports. Why is this important? Well, because you have worked hard on your model, maybe someone else has helped you. A lot of work has gone into this model. So let's get the most out of it that you can. And we're going to start with talking about the different types of results that are available in Simio, some that are generated automatically, some that you can generate sort of custom or on your own. And then we're going to be creating data visualizations and dashboard reports, which is really your vehicle as the analyst to make your recommendation to the business or to your manager. So as the model builder, you have a deep understanding of the model, but for someone else who's not so familiar, it's going to be harder for them to understand and trust the model. So creating data visualizations can be a great way to bolster your claim and build trust in the model and really create a visual tool for others to understand what's happening in the model and what your recommendation may be. So the agenda for today is the following. First, we'll spend some time interpreting model results, specifically the pivot grid. We'll look into experimentation a little bit. Then we'll discuss some different output data sources like logs and output tables specifically. Then we'll work with the dashboard design editor and build some dashboards and focus on dashboard items, filtering the dashboard, and making the dashboard interactive. And switching gears now to the software. Dan, can I get a quick confirmation from you that the software looks good? It's coming through clear?
Yep, I can see everything looks good.
Okay, great. So I've created a model of a simple system here that will be our vehicle to work through most of the agenda. And really, let's just run the model and take a look. So we have a system with 6 registers, just kind of a shopping scenario where we have 6 registers, some patrons with carts, some with baskets. And you'll see as we run the model that things start off kind of steady. So we're starting around 12 noon and running to 8 p.m. Speed things up even a bit more. Towards the mid-afternoon, around 3 p.m. or so, you'll see things pick up, and we'll start to see a bit of queuing. And eventually the system catches up, as we approach turning the lights off, right? And just a quick bit of context as to how I've created this model. So if we look at the source, I'm using a rate table. So we have a time varying arrival rate. We can take a look at that in the data tab. So I have a different number of events per hour. Now remember, this is stochastic. So it's really technically a non-stationary Poisson process. The value that I specify here is plugged into an exponential distribution. So exponentially distributed with a mean of 25 events per hour between 1 and 2 p.m. And we see that pick up in the middle of the day and then taper off. Another feature of this model is that we have a random number of items per shopper. We make a state assignment at the source. I've also displayed that on their basket, their cart, whatever it may be. So you can see, and we'll just click into that. So each entity, each shopper is assigned a rounded value between 5 and 30 for number of items. And as you may expect, if you've ever been to the grocery store, that number of items affects your processing time when you get to the register. And 0.37, folks, is just the magic number that I've identified to get the results that I want for this demonstration. But you can see that we're multiplying that by the number of items. Now we also have a custom server object. You see my server, semi-advanced topic. So the idea is I have this saved off my server, and I've used layers, so I will have to actually add it to the layer to be able to see it. But I have this custom server object that I've basically saved off, and I've added an additional node to, so the worker kind of hangs out where I want them to be while they're helping a customer. So if you're interested in any of the topics that we don't focus on today, please reach out to us, and we'd be happy to delve into those further. Now, what results may we be interested in when we have a model like this? Luckily, our management has given us some good direction on that front. So we can see that the target performance for this system is an average wait time of less than 10 minutes across the entire shift. So for each customer, we hope for an average wait time of less than 10 minutes. We also want to know how many registers and workers are needed to meet this goal. How would a register 1 hour downtime affect our performance? And we're also interested in the utilization of each register. So maybe we'll just start from the bottom here. We're thinking about resource utilization, a pretty common interest, right, when we're modeling in Simio. So how can we really get after that? All right, well, one option is to have some dynamic animation. So for each server or resource, I can attach this resource state pi, so I can see while the model runs, percent time processing, starved, failed, off shift. Again, as we get into the afternoon, the scale tips in favor of processing. But this isn't really what we want to show our manager as a summary, right, or for our presentation. This is more of a monitor for us while we're, just keeping an eye and developing the model, right? So we'll try a few more things. And I want to just give you a little bit more context on the model. So we're interested in how many registers and workers are needed to meet this goal. I have a parameter for worker initial number and system mapped to my worker. And if I set that to 3, you'll see I also have a routing criteria that only allows me to select registers equal to the number of workers. So when we run with just 3 workers, things get pretty ugly pretty fast. So again, thinking about our question, we have some evidence that this will probably not get us our target wait time, but we don't really know. Is it 3, 4, 5, 6? We have to do more digging, right? So let's turn over now for a little bit better insight to the pivot grid. Session's all about results, so we better look at some results. And I don't want to run 3 workers, I don't want to run 5. So we'll fast forward through the 8-hour shift and flip over to our results. Now, one neat feature about the pivot grid that you may or may not be aware of is I can actually filter this down for each column. In our case, we're interested in scheduled utilization. So now we're doing a bit better. We're working towards our answer for that last question on our sheet. We can see now the utilization for each register in the system. But we start thinking to ourselves, scheduled utilization, do I really know what that means, or what that's computed? A great resource for you is the help documentation. So anytime you have that moment where you're kind of curious or you have an intuition about something, but you're not exactly sure, we do it all the time. I mean, I myself use this frequently. Just take a look in the help doc. So we can see that capacity scheduled utilization returns the percent utilization of this resource's scheduled capacity, calculated as capacity utilized over capacity average. Basically, it is time utilized over time available, but the key word is scheduled. So that computation only considers time on shift. And I have a bit of a demonstration just to illustrate that. So we also have this requirement to investigate how a 1-hour downtime may affect our performance. In real life, you may have a probability or likelihood for each register of having that downtime. For this demonstration, I've just selected register 4. And I actually have 2 means of introducing that downtime. We're going to use a work schedule. We're also going to use reliability logic. So I have this work schedule just mapped to model level control here. So I can do 24/7 or a 2-hour downtime. I also have a true false that will toggle my reliability logic. So first, we'll look at the 2-hour downtime using the work schedule, right? Now, the downtime kicks off about 2 hours into the run, so maybe we'll speed it up a tad. Once we get to about 2 p.m., you see register 4 goes white. Okay, and we also have routing criteria to not select an unavailable register. And you can see that things get ugly pretty fast. So again, now we have some evidence that this 1-hour downtime could shake things up. But again, we're still not really ready to go to management with our final recommendation. So we still have some work to do. But what I really want to point out, okay, we run register 4 comes back, and eventually the system catches back up, more or less. I'll fast forward through and see that my pivot grid tells me 36.4 is my utilization for register 4. And it also indicates that I had 1 occurrence of a 2-hour off shift time. So keep this number in the back of your head, 36.4 for scheduled utilization. Now we go back and we're going to do the same exact thing, just a different way. We're going to use reliability logic instead of using the work schedule. So we'll see around 2 p.m., the server is going to go red to indicate that it's in a failed state, not off shift. Same result. You can see looks very similar. The server's unavailable, comes back, the system catches up. So you'll have to trust me that the models are exactly the same. But when I look at the results, now my utilization is different by about 10%. 36.4 versus 26.8. What's the deal with that? Well, we've said that scheduled utilization basically ignores off-shift time. So when I use the work schedule, I get a higher reported utilization, whereas the failed state is incorporated and considered time not utilized. So I wanted to just walk you through that because it's going to be really important for you to make these considerations when you want to get after resource utilization. Just do some simple tests of your own to make sure that the value, if this is a value you may use, is exactly what you're looking for. And if it's not, we provide you with sort of all the raw data there as well, so you can form your own computation or act accordingly. Okay, now let's go back to scheduled utilization. Another point, you may be thinking to yourself, well, Adam, there's a lot of randomness in this model. Like, we're kind of just looking at one replication, right? And if you are, you would be exactly right. So just to illustrate another point here quickly, and I'm following the audience view, I think you can see this. I'm going to snap a screenshot and switch the seed to another replication. Now we'll talk more if you're not sure what I've done, right? We'll talk more about that, but just bear with me for a moment. So when I switch the replication number to 2, we can see that compared to the previous, my results are different. 75% utilization for register 2, 71 for register 2, 26 versus 37. So from one replication to another, the results could actually be considerably different. And we'll come back to that. We're actually going to address that with experimentation and running several replications. So we'll address that shortly. But just remember that if you have variability in your model and you just use fast forward, you're only looking at one replication. It could be a total outlier. You're not really sure. So next, we're going to create some dashboards to get some more visual insight about the system. And to help, I'm just going to flip back to the slides for a moment. So when you're thinking about dashboards, I've mapped it here as a 4-step process. You want to first formulate a storyline. What is your objective? Like, what are you, sort of imagine the plot in your head. What do you want to plot? And then step 2 would be generating output data to ultimately create that chart for that plot. Then we'll design the dashboard using the dashboard editor in Simio, and then we'll present our conclusion. Some other things to consider. Aim for charts that are clear and concise and easy to interpret at a glance. So I pulled some examples from the web, and hopefully when you look at these, you have no idea what the heck is going on. So what we want to avoid is putting time and effort into creating a data visualization that doesn't add value, or maybe even subtracts value, right? So we've said here that no visualization is better than one that is confusing or misleading. And we'll try to put our money where our mouth is on this one and come up with some charts that will help us illustrate the results of this simple example. Just want to do a quick time check. All right, we're doing pretty good. So step 1, formulate a storyline. Luckily, I've already done that for you, so you don't have to worry about that today. I have an idea of what I want to plot. So we know we want sort of this average wait time. So we'll take a look at that first. What we need to do is generate some output data. And there's a couple different ways you can do these things I'm showing you today. So I'm just going to show you one example. When we think about this average wait time, okay, we do have some information in the pivot grid. So we can, for instance, see the holding time in the input buffer at each register, 15, 15, 17. But as we're tasked with the average for all customers, this still doesn't exactly cut it for us. Like, we want every shopper sort of rolled up together. So to do that, we are going to use a tally statistic. And Jeff Smith, who I saw, I believe is in the audience, I once heard him describe a tally statistic as throwing rocks into a bucket. And you'll see why, hopefully, as we set this up. But first, we need to define the bucket, right? So we have our tally statistic element. We know it's going to be a wait time, so we'll go ahead and give it time units. We'll say that we want to log observations, so we can see our results in the tally observation log. So all we've done so far is, we've placed this bucket down on the ground. Next, we'll go back into the model, and one step that I've done ahead of time is each time an entity arrives at the register, I assign this time entered state a value of time now. So when they show up, we assign a timestamp, and that will be in hours, right, to a model entity state that I defined, just a real estate variable. All right. Now our next step will be to throw the rocks into the bucket. And to do that, we have options for tally statistics on some of the objects. So just make a note about that, namely like on some of these basic nodes. So when we're entering, if we want to do a tally, we're actually going to use process logic before processing. So this before processing trigger is right before the entity is actually granted access to be processed. So right when they're ready to roll. And in this window is the duration that we really want to capture. So now to actually throw the rock, we will use a tally step with our tally statistic element. And what is the rock, right, that we want to throw into the bucket is our value expression, which in this case will be time now minus model entity time entered. So for each shopper, we're basically recording the time that they arrived at the register until the time that they were ready to go. And last step is that I want to actually make this logic be generically applicable to every server, and to expedite that a bit, we'll use the properties spreadsheet add-on process triggers to apply that to every server in my model. So you can see now that each server is calling that logic and doing the tally. So now we'll fast forward through, flip back to the results, and look at our tally observation log. So you can see I have all these values now, and this was empty before we did that. So maybe we should have seen that. But the state observation log similarly is empty. We're going to use this in a moment. But you see I have all these values now, minutes. Pretty cool, right? So our next step we're interested in the average. So now we're going to create our first dashboard. And when I create a dashboard, I get sort of the separate window, the dashboard design editor. And the workflow here is basically dropping an item into the dashboard and then mapping it to some output data. So for our first example, we'll take our tally observation log as our data source. We'll see more examples of what data sources are available as we go through. And what I want to display is the value, not the sum, the average value. And using this gear, so the center pane is kind of where we work. I can adjust the way, kind of the look and feel of this card, right? I can rename things. When in doubt, right click on something to try and rename it. We'll call this average waiting time in mins. And I actually liked it better when I did average wait time, so you can see it. We can also rename the entire item itself as average wait. Now, we've done a few things here, but do we have any trust in this number that we're seeing? Like, how do we know? So one thing you could do is save this out to Excel and simply compute the average and check yourself, right? Another thing we can do, as we've seen, sort of how the model runs, well, what if we turn off our downtime and we rerun? Okay, the wait time goes down, so I feel a little better. What if we add full capacity, 6 workers? Okay, so we feel that directionally, we have some faith in this result. And just remember that if you never use this, every time I run, I'm getting a new report here in my log. So this pertains to every run. All right, cool. Now for a next step, we are also interested in a chart showing the wait time per register. So we want to sort of see a breakdown per register. To do that, we're actually going to use an output table. So I want to show you sort of a breadth of different options you have here. So we'll create an output table called table wait outputs with a string, a real, and a string. We'll call this our shopper ID. We'll have our wait time, and we'll also record the register. An output table, if you've never used it before, is a table that I can basically write data to while the model is running. And to do that, we can use process logic to, at some particular point, add a row to wait outputs. And I like to name my steps in the process logic and sometimes give them colors for a reason you'll see in a moment. And then we're going to assign outputs, specifically 3 of them. And when I have multiple, I like to do them all in the repeat group. Kind of up to you what your style is there. But the ID will be our model entity dot name. If you have no idea what the heck that is, dot name is a function that we can use to get a string response, return a string for the name of something, like an object or entity. Next, for our wait time, we'll assign, so another detail I skipped over here, right? With an output table, really your columns are state columns. So you see those columns appear in my state variable name. So I can use an assign step to write to that output table as we're seeing. Similarly to my tally, I want to write model time now minus time entered, but we're going to multiply by 60 because time in Simio is hours by default, and we want our result in minutes. Finally, we'll also write the register as server.name. And what I want to do before I just wing it and fast forward is I'm going to use a breakpoint in the model trace to just see that my logic is working properly, or if it is. We can see that for this entity cart 39, we're adding a row, writing their ID and their wait time. Can we check the model and see that, yes, we actually have entity cart 39 waiting at register 1. Now, if we wanted to write additional information like number of items or anything else, there'd be nothing stopping us. So output tables are a really, really cool and powerful feature if you haven't used these before. So now, as we've done before, let's go back to the 5-worker scenario. Fast forward all the way through with our breakpoint turned off. And we'll see that I now have all this data about the wait time at each register. And it's in a format kind of similar to my logs. So now we can go use this actually for a dashboard as well. So we head back, and we're going to create now a chart using our table wait outputs. Now, when you see the things here, we do have help videos and different examples. So if you're sort of unsure, value is kind of like the y-axis. So I've done something here, obviously, but it doesn't look particularly good yet. series, as you can see when I drag register, will give me kind of a legend, right? What's up with the wait time? You know, it looks pretty big, right, compared to our average. Well, we're actually plotting the sum by default, but we switch to average, and now you can see we're basically aligned with our global average. Now you can also, rename things here as well. So, maybe we'll rename this wait time per register. Okay. And another cool feature, so I'll do you one better. We're going to use cards again. Now we want to make this dashboard interactive. So I'm going to use the cards as kind of an interactive filter so I can compare any subset of these registers that I'd like to. So we put cards. The cards always need a value, so we'll use wait time. And just as we did with the chart, we'll put our registers in series. Now, if you want the value, if you want the sum, that's fine. But you can, again, sort of go in and change the look and feel, get rid of the value. You have some different options to explore there as well. But I want sort of a compact version. We'll rename this as filters. And one more step. So from the data ribbon, I can make this item specifically. So note that the ribbons here sort of respond to what you've selected. Okay. I'll make this one specifically a multiple master filter. And I think it really is best explained through demonstrations. So now I can select with control click any subset of my registers and see the result update in real time. Pretty cool, and a nice way to really sort of make your results sing using cards as a filter. Okay, we're doing pretty well. Maybe just another quick time check. Very good. So we're going to add one more embellishment to our dashboard. So we'll go back into the model, and I'm going to, each time I create an entity, assign this total shoppers state, which I apparently haven't created yet, a value +1, whatever it was already. So we'll create an integer state for total shoppers. And when my shoppers exit at the sink, I will assign total shoppers a value =1. So we're incrementing and decrementing this value as we create and as shoppers exit. Now, another nice source of output data is this idea of a state statistic. So I can call it total shoppers SS, and I can actually basically record values just like my tally log. Every time the state variable changes, I will record a value. So that's sort of the purpose of the state statistic. If you log observations, each time that value changes, I'll write an entry to the state observation log. So you can see at various times throughout the run now, I basically have a tracker, the total number of shoppers in the system. You can see it kick up around 3 or 4 p.m. So initial result looks okay. We'll come back, and I want to add another chart. We'll sort of shuffle things around a little bit so we have some more screen real estate. And now I want to use my state observation log and plot the value over time. I actually want a line chart, but I don't see anything here because I'm plotting sort of across the entire year. So when I switch to exact date, we get kind of a nice signal for our total number shoppers. And I want to call out, the things you see here, okay, are actually the columns in the log. So it can be really helpful to, especially when you haven't rehearsed a presentation and you're trying to actually make this work, to flip back and forth between the log to get a sense for what you need to drag where. So arguments is kind of like your x-axis. So I wanted basically a time series. Now you can play around with the format if you want to see the hour. Another great feature for a plot like this in my design pertaining to this chart x-axis settings is to enable zooming. Love this feature. A colleague of mine showed me this. And now note that average, min, max doesn't really matter. And we'll talk about why in just a sec. But I want to first show you that zooming feature. So now you can kind of hone in anywhere you want to investigate further. Pretty cool. And again, those options you see, right, match up to the column headers here. So since each record, each row is a unique start time, there's nothing to sum across, right? So each value is a unique value. So since my argument is time, it doesn't matter if I select average, min, max, because there's just one data point per. Now, if I had multiple entries or multiple rows here at 1242, then I would have to be cognizant of what option I select there. So just something to be careful about. Now, again, right, it's really important to remember that this is just a single replication result. So you may use this to show kind of an example case, right? But just to reiterate, like if we go back and change the seed and rerun, I think we had 8.98 last time, like, wow, pretty different. So moving on now, what can we do in Simio to handle that variability? So sort of the whole point of simulation, one of the key points I should say, is to capture that variability and run several replications to get a statistically significant result or understand the statistical significance of our results. So we're going to create a few scenarios here. 5 workers with no downtime, 6 workers with no downtime, 5, and let's actually just start there. So if you ever make a mistake, you can always delete a scenario like this. Let's start there. We've already seen that these two do the same thing, so I'm just going to hide 1. We need a 6, and we need a couple responses as well. So we want to look at the average wait time, and we can actually use our tally statistic average. So just like we did in the dashboard, we can write out the average of our tally statistic here in the experiment. We'll also look at the max number of shoppers. Now, another neat trick is if you want to customize the display here, you can use the display name to show like non-standard units, like a count. And for this one, we will use our total shoppers state statistic maximum of all values, right? And we looked at that utilization and saw that that's, also changing across replications. So similarly, you may say this is a percent. And just as an example, we'll look at register 1 capacity scheduled utilization. Let's give this a whirl. So we run 10 replications for each scenario. Give it a moment to churn. And we can see that our wait time is reduced with 6 workers, but we get just a number here. Now, what's so important to recognize is that this is your average across 10 replications. So we'll switch over to the response results to see like a box and whisker output per response. We call this a SMORE plot, a Simio measure of risk and error plot. And what you can see by applying the histogram is that across 10 replications, there's actually a lot of variability for this 5 workers and no downtime scenario. The 6 workers is a little bit more predictable because we have kind of a lot of excess capacity, right? So since that is sort of such a kind of wide confidence interval, we may want to kick up the number of replications to get a better sense of really how much this variability is affecting us at a 95% confidence level. So let's call it there, right? And now you can hover and see that with 95% confidence, I expect my average wait time in this scenario to be between 6.6 minutes and 10.5 minutes. So you can say to your boss, hey, depending on your risk tolerance, we may be okay with 5 workers, but our confidence interval does go a bit over 10. So, just that would be, right, perhaps your real conclusion. Okay. So really important to remember to kind of use the experimentation, run multiple replications when you have a stochastic model. Still doing okay on time. I'll spend about maybe 4 more minutes on this model, and then we'll have a stopping point. I have a little more I can show you. We can see how many questions. So we'll check in just a few minutes, but let me just wrap things up here. What I want to also show is 5 workers plus downtime, or 6 workers plus the downtime. So we'll check, check, and let's run 30 reps for each. So now we'll see, now we're really addressing that question. How does the 1 hour downtime affect our ability to perform and meet our objectives? So we perhaps concluded that we feel okay about 5 workers when there's no downtime. But as we're already seeing some evidence, that 1 hour downtime really kind of shakes things up. So you may ultimately conclude, hey, if we have a register go down, we may need kind of a 6th worker to at least flex during that downtime so that we can keep 5 registers open. Now, it would take sort of further modeling and testing if you wanted to test that. Like, what if we just have a 6th worker when the downtime occurs to keep our metric under 10 minutes? Right. Finally, another neat feature that you may not know about, if you see a crazy outlier and you're like, what happened there? You can use export details to actually see information about each replication. So we'll give this a sec to zap up in Excel and pull it over, and we can apply filtering. Let's sort this largest to small, and we see this kind of replication 25. It's like, what's going on with that? Where we have, 63 shoppers in the system, right? So if we look at max shoppers, we had 63. So they're all sort of correlated. If you wish, you can go back to the model and just investigate. If you're curious, you want to confirm that you didn't make a mistake, you can run. So that's really the purpose of this randomness option. Oh, that doesn't really help when we fast forward through and can't see anything. But ultimately what we find is that just our arrival rates must have been ramped up. Our number of items must have been hit in big numbers of items, because there's nothing different about this scenario, but we do end up with some really substantial queues, and it just kind of overloads the system. Like, the system doesn't really catch up like it did in the other cases. So just kind of a worst case scenario, but pretty cool that we can drill into that. Finally, folks, and I was going to build this live, but we'll just take a look at it. You can also build dashboards within the experiment, which is a really nice touch. So now you have a dashboard that is statistically significant. So just word of caution that your interactive or single rep dashboards are really just kind of an example result, and you have to be sort of clear about that. But now I can look across my different scenarios, for example, and see how my register utilization is affected. And I want to mention to you another important feature of dashboards is the ability to filter your chart items. So I'm glossing over this a bit, but same idea. We have data sources. So in this case, I use experiment statistics summaries. I have 4. One of them we just exported. Right, so you have sort of different data sources within the experiment, like this pivot grid or the raw data behind these charts. Those are really your sources. So summary details, summaries details that are your sources for your experiment dashboard. And I basically wanted to filter this down to just data item scheduled utilization. So we'll go back, and I promise I'll pause here in a moment. So I add it as kind of a hidden dimension so I can apply a filter. So I say data item equals scheduled utilization, object name contains register. If I take that off, I get all my workers as well. So you may or may not want that, but just wanted to show you kind of the ability to filter per item. And that is about where I wanted to wrap on this model. I do want to just point out, you also have a Gantt chart It's a discussion about results. Nice way to see that your processing times for each entity at each register are in fact different given their number of items. Okay, so another kind of nice at a glance result here. But that's it. So Dan, how are we doing?
Good, good. So before you go into, I know we've got about 15 minutes left in the session, but before you go to the next model, so you spent obviously time behind the scenes creating this model. Do we have, actually two parts of this question. Do we have sample models or example models that customers can use to explore this topic that are available to them? And then the second question is, because this is a model that you created, is this model something that you'd be willing to share if someone would want
Of course, yeah. Always happy to send this out, make this available. Just shoot us an email. We could do that, no problem. To your first question, yes, there are some really good examples, and honestly, those are have been a great help to me in learning how to be comfortable with dashboards. So you have a couple options in Symbits, right? We're never too experienced for Symbits. So pop in dashboards, and you have a couple different options there. Specifically dashboards within experiments. I think I have that open as well. So you can see, you know, an experiment with different dashboard reports within the experiment, and you can crack into the editor and see how we set it up. So this is really, really quite helpful. So Symbits would be one option. Your other option there is our example models. Yes, better save my work. Our example models, specifically the scheduling examples, scheduling discrete part production, etc. You can see we actually have a Symbit on the scheduling examples, have sort of more advanced dashboards, which is where I would take us next. Unless we want to do some Q&A, I can show you some of those more advanced dashboards. But yeah, great point there, Dan. We do have some good resources for folks out there.
Okay, good. So to answer the question that came in as far as Adam sharing this model, I will bring my email address up one more time before we end the session today. So you'll be able to send an email directly to me, request the model, and we'll make sure we get it to you. One other question popped up, Adam, before you jump into the next model, and I think you may have addressed this, but I don't want to say for certain. Are you able to pull in different data sources into the same chart?
Into the same chart. So that is a little bit of a tricky one. You sort of can, but so you can pull multiple data sources into one dashboard, like we've seen, but sort of one-to-one, like one data source per item, right? So we'll go back into the designer and see that this item has one data source, this item has another data source. The answer to the question is yes, but you need to create a new data source, basically using this data federation to create sort of a merged data source. So you can have like sort of data operations that you may be familiar with, like join, right? And just disclaimer, I'm not the most well-versed on this. If you are interested and you have a use case, maybe reach out to us or our support team, because I know we have people who are experienced with this, but you can basically create a new sort of merged data source between, you know, two or multiple of your data sources to apply to one chart item. So the answer is yes, through that mechanism. Yep.
All right, perfect, thanks. Now we do have, I've got several other questions, but why don't you go ahead and do your other model, and if we do have any other time left, we'll address these questions. If we don't get the chance to address the questions individually here, we'll make sure we get the questions answered individually on the side.
Yeah, very good. And you know, I do wanna hear from the audience, so I'll be pretty brief here, and maybe I can use this as a vehicle to answer questions. This is just sort of a full factory example we've created, right? So you have kind of a biopharmaceutical manufacturing environment with batches of product kind of flowing through bioreactors. Then we have kind of a purification and recovery in the middle. So you'll see this batch one kind of come down the line before it's produced to stock in a freezer, from which we consume to fill orders down the line on the downstream here. And our cases of vials basically go through this deep freezer, this lyophilizer, and are produced to stock to fulfill actual customer orders for drug A or drug B. So as you can imagine, this model compared to the other has sort of a lot more information and data. So I just want to show you some more flavors of dashboards, right? So we have materials and inventory, right? So we can see our raw goods and our finished goods. So our drug substance, we have some WIP that we consume, and then it goes up and we consume again. We can look at sort of a utilization per resource. So we have some evidence that this lyophilizer is a bottleneck. We can see it's pretty highly utilized. We can also look at the task information for any resource. And these are sort of those scheduling dashboards you would see, so you could crack into them further if you want. We also have a constraints Pareto, which is pretty cool, where you can see kind of the cumulative time for different types of constraints in the model. I'm going to show you a quick example. I have these filling operators on the downstream. I say there's only 3 of them, so we don't see anything related to filling operators. We'll go back to our Gantt chart and see that filling is pretty smooth. We have that long tail for the lyophilizer. Basically just has a long cycle time and doesn't keep up with the upstream. But we run, and now anywhere I see hashing on my Gantt chart indicates that there's been a constraint. Really what we can see is that these filling orders need 2 filling operators for the transfer task, but my fill line simultaneously needs 2 filling operators. So I only have 3, 1 and 2 are over here. 3 is up here waiting for a friend to help out. So we have constraint time, right? And then in our dashboard, we now see 215 total hours constrained by filling operators. So it's a pretty cool tool for debottlenecking the system. And yeah, okay, I think we can do this in 2 minutes. So let's just close the loop, right? We see this big lyophilizer constraint. We also see a bioreactor. So the bioreactor is kind of a necessary evil, very expensive piece of equipment, 20,000 liter bioreactor with a long cycle time. So it's going to be highly utilized. But management has some appetite in this scenario for what if we add a second lyophilizer? All right, and I will do this as fast as I can, which I've done it before, so it's pretty quick. Just 2 quick kind of waves of the wand there to tell my model that I'm creating this scenario with 2 in parallel. We actually have a data generated model here. So I copy lyophilizer 1 and give it a new name. And I'll adjust its coordinates to the right slightly. Wow, pretty cool. So now we have 2 of these. And I'm going to tell the upstream that I want to route to both of them, and I'll add this to my node list. So just like that, we have created a scenario using our data generated modeling where we have 2 lyophilizers in parallel. And we can fast forward through again to see basically now that I'm keeping up quite well on the back end. That constraint has totally been eliminated. So the way I was writing that constraint was only sort of time after the last order. But interestingly enough, with 4 filling operators now, I have a bit of a hard time keeping up. So hopefully that's, you find that perhaps interesting to see how we can use dashboards for really debottlenecking the system in some cases. And that's all I have for you, Dan. So we'd love to answer a few questions with the time we have remaining.
No, that's great, Adam. Thank you very much. So, of course, as it normally goes, we had a very, very few questions at the beginning, and they've been coming in hot and heavy here towards the end. So I know we're going to run out of time. So what we're doing for everyone who's asked a question, we are taking notes of these questions. We will make a point of responding to everyone individually with the questions that they answer or answers to your questions. Let me grab control back here real quick, maybe. If it's gonna let me. No. Can you give me control back, Adam? Because it's not letting me grab control.
Yeah. Change presenter to Dan. Yes, you should be good to go.
All right. And as load it back up. All right. So as we're winding down here at a time, I just wanted to bring up our future schedule as an example and answer the main question that has come up multiple times. And the question is, where is this session going to be available to watch? So we are going to have this session available on Simio.com immediately following this recording, or immediately following when we shut down the recording today. So anyone that wants to go back and watch what you've seen here today, or rewatch what you've seen, or pass it along, it'll be available on Simio. The next three sessions are on the screen, as you can see: Friday, May 20th, Friday, June 3rd, and Friday, June 17th. Any questions that you may have that have come up today, or anything you are interested in as far as getting the model shared, things like that, my email address is shown at the bottom. Feel free to reach directly out to me. One suggestion that came up during this call was potentially creating some sort of share folder or something where we collect the models in and we share them there. We'll take that into consideration and see if that makes most sense going forward. But if anyone is interested in the model from today, just email me and we'll figure out how to get it to you. Otherwise, like I said, the questions are too many to answer in a couple minutes of time. We will make sure we get answers back to your questions accordingly. To wrap up, Adam, anything on your side?
Nope. Thank you for joining.
Yep, everyone, thank you very much for joining. It was a great first audience here today for our first one. We look forward to similar type audiences in the future, and I will look forward to hearing from you with any questions that come up, and you can expect to hear back from us in the near future on your questions that came in. Thanks again. Thanks, Adam, and we'll talk to everyone soon. Goodbye.